what does the Pythagorean theorem say? Okay, so what does A, B, and C represent? And C is the? And we only use that when? It's a right triangle. A squared plus B squared equals C squared does not work if it's not right. Okay? All right. Well, the converse of the Pythagorean theorem just says the opposite. If A squared plus B squared equals C squared, then you have a right triangle. So that's the converse. All right? Flashcard. I mean, it makes sense. It goes both ways. If we know we have a right triangle, then we can use the Pythagorean theorem. If we use the Pythagorean theorem and it works, and it makes sense, then we have a right triangle. That's all that that's saying. Okay? And because 7.1 was a Pythagorean theorem and we've already been using it, we're not going to go on to that section. Okay? All right. So what we need to remember from chapter, I think it might be 4, was this, or maybe 5, was this little piece of information here. Emma, would you close the door for me, please? Thank you. And this was how we determine whether or not we have a triangle. Remember, the sum of the two sides always must be greater than the third. And that's what those 3 little reminders are saying. So you might want to go ahead, just as a reminder, and put this in your note cards too. How do you know when you have a triangle? When the sum of the two sides is greater than the third. Okay? Now, the Pythagorean theorem, though, allows us to determine now what kind of a triangle we have. And this you do want to have in here. If A squared plus B squared is greater than C squared, then the triangle is acute. If A squared is plus B squared is less than C squared, then the triangle is obtuse. Okay? A and B are always the smaller than C. Yes? So if you ever look, angles are always marked with large letters, capital letters. Sides are marked with lowercase. Okay? So if C is our right angle, then that side C is always across from that. Okay? So what we're saying is we're identifying C, in this case, to always be the hypotenuse, and that's what we're comparing it to. It's going to be the longest value. So if we square A and B, which are our sides, and it turns out to be greater than what C is squared, it's acute. And if it's less than what C is squared, then it's obtuse. Okay? Uh-huh. You can do one. You can do one. Okay, so let's see. The first thing we always want to do, we don't want to assume that we even have a triangle. So the first piece of work that you have to show is, do you even have a triangle? All right, so you always want to show, 1, do you have a triangle? And then 2, you tell me what kind. Okay, so how do we prove if we even have a triangle? What do I need to do? What do I do, Aaron? And so do I just go 11 plus, is 11 plus 20 greater than 23? Do I just do one case? I have to do all 3 cases, right? So as that one works, is 20 plus 23 greater than 11? And is 23 plus 11 greater than 20? And yes, I know you can do this in your head, but I'm big about showing your work, so just put that down, okay? So make sure you're showing that. All right, then what do we do now to tell me what kind? What would I need to do? Sydney? So we're going to figure out, we're going to do A squared plus B squared, and we're going to figure out how it compares to C squared. And what do we know C is going to be in this case? C has to be the longest leg. So we'll do 11 squared plus 20 squared. How does that compare to 23 squared? Well, you do it. Is it less than or greater than or equal to? So you need your calculator for this. All right, I want you all doing this. And you can just plug that in. You can just go 11 squared plus 20 squared and pop out an answer. Okay, what do we get? What is this? 5 hooey? 521? And what is this? And so therefore we're going to make this as our inequality, and that tells me what? Is it obtuse or acute or right? Yeah. A squared plus B squared is less than C squared, so we know we have obtuse. Does that make sense? All right, so try the next one. What makes this one difficult or different is the fact that we have the square root of 41 going on. Well, no, we'll just go further on and say what kind it is. All right, so I don't know which one's my longest side. Which one is my longest side? What do you think? What is, Emma, do you know what 2 square roots of 41 is? Really? I don't think so. 12 point blah, blah, blah. Okay. Ah, I gotcha. She was putting it back under the radical. Gotcha. Okay. So therefore, 2 root 41 is our C. Would you agree? All right. So is 10 plus 8 greater than 2 square roots of 41? Because we know that 2 root 41 is 12.8, right? All right. Is 2 root 41 plus 10 greater than 8? Obviously, that works. And is 2 root 41 plus 8 greater than 10? Yep. Okay. So now let's determine what kind of triangle we have. So we're looking at 10 squared plus 8 squared, and we're trying to determine how it compares to 2 root 41 squared. So this is 164. What's that? Is this also 164? And so we would therefore say that these are equal, which means that we have a right triangle. Yeah. You can know in your mind that it's 12.8, but yeah, I want you working with the original. Yes, please. Okay. Can the segments with lengths of 11.2, 6.5, and 7.1 form a triangle? Classify the triangle as possible. So we got to do, it's the same thing. Is 11.2 plus 6.5 greater than 7.1? Yes. 6.5 plus 7.1 greater than 11.2? Yes. How about, what's my last combo? And that's going to be greater than 6.5. Okay, so you figure out what kind of triangle we have now. You do the work. All right, Lainey, what I get over here on the left? 90 who? All right, and what did I get over here, Paige, on the right? That's this. What do we have? Are we good? Easy sneezy?